That is not blood. That is a tree. And for thousands of years, nobody fully understood why it did that. Modern research has finally revealed much of the reason. Socotra Island sits in the Indian Ocean off the coast of Yemen. It has been isolated from the African mainland for around 20 million years, long enough that roughly a third of its plant species exist nowhere else on Earth. The dragon blood tree is the most recognizable of them. Its canopy spreads horizontally like an umbrella, dense, flat, providing maximum shade in minimum space. It looks designed like something an architect drew rather than something that grew. The shape of that canopy is not accidental. It is one of the most efficient survival structures in the plant kingdom, and researchers have only recently confirmed exactly how it works. The tree grows slowly. Some of the larger specimens on Socotra are estimated to be several hundred years old. They grow in rocky, nutrient-poor soil on steep hillsides where almost nothing else can establish itself. And when anything cuts into the bark, an animal, a tool, a falling rock, that dark red resin runs immediately. People noticed that resin a very long time ago. What they did with it runs through some of the most significant civilizations in human history. Ancient Romans knew about this resin. They called it cinnabari and traded it across the Mediterranean as a dye, a medicine, and a varnish. Medieval Europeans used it to color and preserve wood. Some researchers have proposed that dragon blood resin may have been used in certain historical violin varnishes, though this remains debated among historians and instrument makers. What is not debated is that people were traveling to one isolated island in the Indian Ocean, specifically for this red liquid, for over 2,000 years. In traditional medicine across the Middle East and parts of Asia, it was applied to wounds and mixed into compounds prescribed for fever, digestive problems, and infections. Whether the treatments worked as intended is a separate question, but modern studies suggest there was more science behind those practices than anyone realized. If you are finding this interesting, subscribe to this channel before we continue. What scientists found when they properly analyzed this resin is the part most people have never heard. When researchers began properly analyzing dragon blood resin, they found a high concentration of compounds called flavonoids, specifically dracorubin and dracorhodin, which produce the deep red color. These compounds have documented antimicrobial properties. A 2011 study published in the Journal of Ethnopharmacology found dragon blood resin active against several strains of bacteria, including some that have developed resistance to standard antibiotics. Researchers are now investigating whether compounds from this tree could contribute to treatments for antibiotic-resistant infections. The people applying this resin to wounds 2,000 years ago did not have the language to explain what they were doing. Modern studies suggest the chemistry was doing something real. And the canopy, that flat umbrella shape that looks designed, it is. Socotra receives much of its moisture from fog and low cloud rather than rainfall. The horizontal canopy catches that moisture and channels it down toward the root system. The tree is harvesting moisture from fog. The shape is a collection mechanism built over millions of years of evolution on a dry island. Everything about this tree that looks unusual has a reason. The shape, the color, the resin, all of it. Understanding why the tree does what it does has arrived at the same time as another discovery. The tree is disappearing. A study published in 2021 in the journal Biological Conservation found that dragon blood tree populations on Socotra are declining significantly. Several things are arriving at once. The fog and low cloud the trees depend on for moisture has been decreasing as regional climate patterns shift. Cyclones, historically rare in the Arabian Sea, have become more frequent and more severe. Two major cyclones hit Socotra in 2015, damaging large areas of forest that had stood for centuries. And the young trees are not replacing the old ones. Seedlings that germinate struggle to survive in changing conditions. The researchers who ran the 2021 study projected a significant decline in dragon blood tree populations by 2080 if current trends continue. This tree survived around 20 million years of geological isolation. It may not survive the next 60. Conservation efforts exist. Socotra was designated a UNESCO World Heritage Site in 2008. There are programs working to protect and replant. But the conditions the tree evolved for are changing faster than conservation can fully respond to. This tree has been producing that red resin for millions of years, long before anyone knew what it was made of, long before any of the research that now explains it existed. It just kept doing what it had always done, on its island in its fog. Whether it gets the chance to keep doing that depends on decisions being made right now, by people who will never visit Socotra and may never have heard of this tree before today. There are thousands of plants doing things like this right now, things nobody has properly explained yet. That is what this channel is here for. Subscribe to this channel. Share this with someone who thinks they know what trees are capable of, and come back for the next one. See you there.